Well, hello again. So today we are going to continue our worked example, and today's session we are going to discuss the next step, which is assigning boundary conditions. So if you remember in session number 1, when we created this template 3D model, SAP automatically generated some boundary conditions or support conditions at the column base over here. So these are the ones that you see here in green color. So the boundary conditions that SAP automatically generated here are pinned conditions. So these are the ones that are highlighted here in SAP using green triangles. So the green triangles here at the base of the column represents that the column is pinned. You have in each direction. So you have a green triangle oriented in the YZ plane. So this means it's pinned in this direction. And you have another green triangle oriented in the XZ plane. So again, this means that the column is pinned in this other direction. Pinned, of course, meaning that this is a hinge or a pin support that doesn't transfer any moment. But in reality, we might have different type of constraints and boundary conditions that we want to assign to our model, which is actually the case here, because if you notice in the two-story building that we are analyzing, in the XZ plane, we see that the moment frame in the XZ plane have fixed supports, while in the YZ direction, the braced frame has pinned connections. And actually this is also illustrated here in this 3D view. So the gray rectangles demonstrate that you have fixed condition in this direction, and the pin supports represent that you have a pin support in the other direction. So we want to modify those boundary conditions that has been generated by SAP and do our own. So how can we do that? Well, we said from before that from now on we have define and assign to use in every step. So in this case, I will select the point. So if I select those points, those 4 points, and then I go to assign, and now I'm not assigning something to the frame, I'm not assigning anything to the area, I'm assigning something to the joint or the point basically. So if I go to assign joint, and then if I select restraints. So if I select restraints, so you will get this menu over here, and it tells you what do you want to restrain. So whatever you are going to check is going to be restrained. Now, since this is a 3D model, so you know that at any point you have 6 degrees of freedom. Displacement or translation in X, Y, Z, and rotation about X and about Y and about Z. So you are being prompted here to select which degrees of freedom out of those 6 you are going to restrain and which you are going to release. There are some fast restraints like shortcuts. So basically, if I want it fixed everywhere, I can click on this icon for fixed, and automatically all 6 degrees of freedom are checked, which means all 6 degrees of freedom are restrained. I can click pin, so only the translation degrees of freedom are restrained while rotation is allowed. I can select a roller, meaning that only the vertical translation degree of freedom is restrained while everything else is allowed to move. And the last one is free. Basically, there is no restraint at all. Now you should note here that this is not called the translation X, Y, Z or rotation about X, Y, Z. Things here are defined with respect to three different axes, 1, 2, 3. So 1, 2, 3 in this case, they are corresponding to X, Y, Z. So axis X is called here 1, and axis Y is 2, and axis Z is 3. 1, 2, 3 are the typical local coordinates notation that we use here. So the global coordinates would be the X, Y, Z, and the local coordinates would be 1, 2, 3. So every point has local coordinates 1, 2, 3, which in general, by default, they coincides with the global ones. So 1, 2, 3 by default coincide with X, Y, Z, the global one. Every frame element has its local coordinates as well. We were going to talk about this when we are looking into the results later on. And every shell or area element has its own local coordinate X, 1, 2, 3, which may or may not coincide with X, Y, Z. Okay. So now we are talking about the points, and again, with respect to the point, the local coordinates correspond to the global coordinates. So in my case, let's go again and check what we want to do. So at these 4 points, 1, 2, 3, 4, we want to have it pinned in the YZ direction and fixed in the other direction. So, okay, let's go about it a different way. So this means that let's fix everything. So now everything is fixed. So let's go backward now and let's say, what do I want to release? What kind of rotations I want to allow? Well, I want to allow the rotation around X. So I want to allow the rotation around X, because if this is the X axis, I want to allow this point to rotate around it so that it become a pin or a hinge. So X is 1, axis 1. So this means I want rotation about 1 to be allowed. Okay. Rotation about 2, which is the rotation about the Y axis, this is in the other direction. This needs to be fixed because this is what we chose. It needs to be fixed. Rotation about 3, which is rotation around the Z axis, which is basically torsion. Are you allowing this point to twist, to rotate around the Z axis, to twist? In this case, no. In reality, in typical structures, we never allow this. So that's why I'm not allowing the rotation around 3. With respect to translation, well, the point is fixed. This is a typical structure, so this point is not allowed to move left and right or upward. So the translations are all fixed with respect to the 3 coordinates. If I click apply, you will see here that now you have a rectangle representation of the fixed support in this direction, and you have a triangular representation of the pinned support into the braced frame direction. While I'm at it, let me also select the 2 interior supports, and those ones will be fixed everywhere in both planes. So I will just select the fixed support and click apply, and that's it. So now I defined the end boundary conditions or the support conditions for my structure. Let's also talk about something else. If you remember, we said regarding the braces that the braces were assigned some releases. for the moment at their ends, because the braces are pinned members, and pinned members need to have pinned ends and the boundary conditions. So when we drew these braces, if you remember, when we drew these braces using the draw frame option, we selected, if you remember, we selected the pinned option. But how about if you didn't do that? Or actually, if you look at this beam, so the beam at the CBF, let's actually look into the XZ plane, or sorry, the YZ plane. So these two beams, this beam and this beam, if I look at my example, in the description, you will see here that those two beams also have a pinned condition. So I need to release the moment at their ends. The same for the top beam. The other beams in the moment frame direction, they have a fixed support, so a fixed connection. So they remain as they are. But the other ones into the CBF direction, they will have some kind of pinned connection, like maybe a shear plate connection, something that can be simulated as a pin connection. So I need to represent this moment release. So how can we do that? Well, you need to select the beam. Of course, here notice that the beam is divided into two elements because we have a breakpoint here. So you need to select each part of the beam. So I selected here the 4 beams, and then there is also the 4 beams on the other panel. So if I go to the 3D view, let me also select those as well. So now I selected 8 frame elements, and I need to release the moment at their end. So how can you do that? So again, you need to go to assign, you need to go to frame, because this is a frame, and then you need to select releases or partial fixity. So you need to select that. And now you will get this dialog box, and this dialog box is telling you what degrees of freedom, or in this case the forces, the forces corresponding to the 6 degrees of freedom, do you want to release? Well, I don't want to release anything related to the axial load or the shear forces. I'm interested into the moments, so M22 and M33, which are essentially the moment around the y-axis of the cross-section, which is the weak axis, M22, and M33 is the moment around the strong axis of the frame element cross-section. So I am interested into releasing those. So I'm being prompted to choose, do I want to release the moment at the end or at the start, because I have a frame element. So where do you want to do that? Well, let's simplify things. Let me clear the selection again. Let me clear the selection, and let me just select one element. Let me go into the YZ again, and let me actually go at x equal to -6, which is the first panel, and then I will select this element. So now I want to release the moment at this end, but we are not sure, not this end. This end will remain fixed based on our problem. This end will remain continuous. So I'm not breaking, I'm not putting any pin connection here. This is a continuous beam. But at the beam to column connection, I need to have a pin support or a pin connection. So I don't know. So here I need to release the moment. I need to select what I want to release. If you remember so when it comes to the support, we will checking what we want to constrain. Here is the opposite. Here we are selecting what we want to release. So I'm not sure if this is the start or the end. This depends on how you drew this element. When you first built or constructed this element, what was the start and what was the end. But that's fine. You can select the end. So I want to release mx and my at the end. And the stiffness, it will be 0 because I want it completely pinned. If I want it to be something between pinned and fixed, so I have it like partial fixity, then I may need to specify some kind of stiffness. But in this case, I want it to be completely pinned, so I will put it as 0. If I click apply, so now automatically you see the green dots. If you remember, the green dots represent the presence of fixity. Okay, so now this means that my selection here was correct, that actually this is the end of the frame and this is the start of the frame element. If I did a mistake, that's fine. Then you can change your selection and click apply again. So this is done. Let's try this frame element. So again, let's say that this is the end as well. Let's say apply. So this is not correct. I want the pin, the green symbol, to be the other way around. So let me select it again and choose start and click apply. So now this is correct. Now I can do the same for the others. So now let me look at the 3D view. I will select those similar elements. Let me zoom. So I click on those 3, say apply. They should have, so this is a bit different. It has a different orientation. So let me select again. And let me invert this. So say apply. Okay, that's good. Now for this one, let me say apply. Okay, correct. Now those are the ones that are remaining. Let me click apply. No, not the right location. So let me use release at the start, not the end. Click apply. And that's it. So now I have the releases. I double check all the green points in the braces, correct. All the green points in the beams at the right locations. This is fine. Here, the green points, right location, everything is correct. So now everything is done, everything looks good. So this is if you want to assign this frame release at the end. So this covers what we called the point constraints. Now there is something else that's called in the assign. There is restraints and there are constraints. So what are the constraints? Well, constraints or restraints, let's start with the first one, which is the one that we just covered. Restraints refer to the boundary conditions at a single point. That's why the icon here, it has like one red point, that's it. Constraints is applying boundary conditions between a group of points. That's why the icon here has 4 points connected together. So in constraints, if you open it, first you need to define a constraint, which you can actually do it directly here, or you could go first to the define menu, define constraint, and then assign it to some group of points. Or you can automatically click on this button, which will open the define a constraint dialog. So if I click on this one, there are different type of constraints that you can apply. There is a body constraint, diaphragm, plate, rod, beam, equal, local, weld, line. So again, if you look at the definition of each of those, what those means in the SAP manual, you will understand what each one of those different constraints does. In brief, each one of those is just a shortcut or just a packaged constraint boundary condition that controls a few points in a specific degree of freedom. So diaphragm, for instance, diaphragm meaning that if all the points at the same level or at the same elevation are expected to move in X and Y direction the same, for instance. So let's say that you have here a floor slab, which is the concrete floor slab that we have. So this means when one point is going to move or displace, the whole thing will behave as a diaphragm, a rigid diaphragm, and all of them are going to move rigidly together. They are connected rigidly together. So if you want to simulate that, then you add a diaphragm constraint. If you click on add new constraint, you need to give it a name first. So you can call it diaphragm 1 or something like that. And then you need to specify the constraint axis. So this is the axis perpendicular to the diaphragm plane. So if I'm trying to create a rigid diaphragm in the XY plane, then I need to select here Z as the constraint axis. And then I can click OK. So now it's defined. Now that it's defined, I can see it here into the assign constraint. So now if I select all these points, let's say I select all the points at the top floor, and I select the diaphragm and I click apply. So now all those points are connected together with the diaphragm constraint. And I can do the same for the second floor, and I click diaphragm and I say apply. Okay, so having a diaphragm is a very diaphragm constraint in buildings is very common to apply actually when you're running something in SAP. If you want to avoid things like twisting of individual members in your structure. And in reality, it's a very good representation, because in reality you have, again, you have a floor slab that's connecting all the floor points together. All right. So again, if I go back to the define, the constraint, again, body, diaphragm, all of those again are similar things, but I'm attaching points using different degrees of freedom. Equal, for instance, equal. If you select equal and you say add new constraint, well, as the name tells you that equal, meaning that you are going to connect a number of points using equal degrees of freedom. So you just say, you want to say that all the points will have the same degree of freedom, equal degree of freedom with respect to X translation or rotation around the X. So if one point moves by 5 millimeter, all other points in the constraint will move by 5 millimeters in X direction. If this point rotates by 1 radian, all the other points will rotate by 1 radian. So actually, if you remove the rotations and the translation in the Z direction and just keep equal degrees of freedom, the constraint X and Y, this basically becomes a diaphragm constraint. Okay, so if I use an equal constraint, just x and y, it becomes corresponding to the diaphragm constraint that we just defined for the flow level. So again, you can read more about those in the SAP manual, all the different types. They can be very useful. Some of them can be very, very useful if you are trying to simulate some kind of mechanical connection or something like that. So the diaphragm is not only important for floor movement, but also if you have like some kind of concrete wall, like structural wall in one panel. So in this case, then you will need to select, let's say, like the points around this wall and assign them some kind of diaphragm to say that they are moving in this plane, they are moving together as they are rigidly connected. Okay, so this concludes our discussion of constraints, restraints, which is basically boundary conditions in general. Next time, now we are going to move to the next step in our workshop, which is, now we are done with the geometry and the boundary conditions. All is done. So now it's time to start defining the loads and then assigning the loads. So this is essentially the last step before we actually run the model